Good morning, everyone, and welcome to e-learning time. My name is Juanita King, and I'll be your chemistry teacher for today. Today, we are going to be looking at equation writing. By the end of this lesson, I expect you to be able to fulfill the following. Let's see. You will be able to observe some common laboratory reactions. You will be able to write chemical equations, balanced chemical equations, and you will have an appreciation for why it is so important to be able to write balanced chemical equations. So if you know that this is a topic that you need to be a part of, go and get your pen and your paper and get ready. If you know you have a friend that needs to hear about this or be reminded about this, then get them ready as well. Okay? In order to be able to write balanced chemical equations, I recommend that you know your ions and be able to write chemical formulae. That will help you a great deal. So let's get right to it. So what is a chemical equation? A chemical equation is a shorthand representation of a chemical reaction. Now, we do chemical reactions all the time in chemistry. And if we had to write every chemical reaction we did in words, that would take forever. So we have designed a way that you can write chemical equations using a shorthand method that is really fast. Good. So what does a chemical equation show? On the left-hand side of a chemical equation, you have the reactants. And on the right-hand side, you would have the products. And between the reactants and the products, you will see an arrow pointing towards the products. Now, in case you don't remember, the reactants are the starting materials. So whatever you start the reaction off with, those are called your reactants. And the final materials are called the products. Here's an example of a chemical reaction. Here we have sodium reacting with water to give you sodium hydroxide and hydrogen gas. Look at how simple that is to write. One line, that's all it takes. However, if we wrote that same equation in words, we would have to say it like this. 2 moles of sodium solid reacts with 2 moles of water to form 2 moles of sodium hydroxide and 1 mole of hydrogen gas. Imagine having to write something like that all the time. It's much easier to just write that one line that contains all of that information in a nugget form. Next slide. What else does an equation show? Look at that colorful equation again. In blue, you will see the reactants. Which side are they on? They're on the left side. In purple, you see the products. In that lovely shade of gold, you see the state symbols. Sodium is solid. Water is a liquid. Sodium hydroxide is aqueous. What does aqueous mean? It means that it is an aqueous solution, a solution that is made by dissolving the solute in water, in this case, dissolving sodium hydroxide in water. And we have hydrogen gas. So a little G there represents the hydrogen gas. What else does an equation show? It shows you the number of moles. If you're in Form 3, this might be a new term. But don't get scared by it. It's just another unit of chemistry. So you can have a unit like mass being expressed in grams. In chemistry, we express the number of atoms in terms of moles, number of particles in terms of moles. Okay? So look at our equation again. In the lovely shade of, what's that, orange, we have 2 moles of sodium. We have 2 moles of water. 2 moles of sodium hydroxide, and there's no number in front of the hydrogen, and we know that that means 1. When you see no number, that means 1 because 1 is understood. That's my mantra. And the last thing that an equation can show you is the reaction conditions. Now, some reactions need certain conditions in order for them to occur. For example, that's right, they might need some pressure, or it might need heat, or some form of light to be added, or catalyst. You can place those conditions over the arrow, okay, or under the arrow. Next slide. Right. So let's get right into how do we go about writing chemical equations. And when I say writing chemical equations, I mean from the beginning to the end, you know, balanced chemical equations. Step 1, if it is not provided, you need to write the equation first in words. Let that be your guide. Write it in words. This will help you determine the reactants and the products, the state symbols, and the conditions. Take a look at that reaction that is taking place there. We have some magnesium reacting with hydrochloric acid. And if it was moving, you would be able to see lots of bubbles, lots of effervescence, okay? So what is happening here? The magnesium ribbon is reacting with a solution of hydrochloric acid to produce a solution of magnesium chloride and hydrogen gas. Look at it go. Isn't chemistry awesome? Look at it go. Look at, you can see the magnesium ribbon is reacting vigorously with the hydrochloric acid, and you are getting some products being formed. Definitely a gas is coming off. And you have to use your imagination, but believe that a solution is also being formed called magnesium hydroxide. Now the equation, right, the equation, when it is written in words, would look like that bottom line. Let's see that bottom line. You have the magnesium ribbon plus hydrochloric acid solution to give you magnesium chloride solution and hydrogen gas. Did you hear what I did just now? Let's go back again. Let's look at the first plus. So the magnesium ribbon, highlight that first plus for me. That first plus means reacts with, because this is on the side of the reactants. So we're saying that magnesium is reacting with hydrochloric acid. But on the product side, let's zone in on that plus. Nice. So that plus means just and. So we got we got two products from this reaction. Magnesium solution, magnesium chloride solution and hydrogen gas. Very good. So that's the equation in words. What's step 2? Step 2, we are then going to write the correct formula and state symbol of each reactant and product. You're going to write the correct formula. You know, if you struggle with chemical formula writing, then this is where it might get tricky for you. So remember, you must be able to write your ions. You must know your ions so that you can write proper chemical formulae. And if you can't remember how to write chemical formulae, I did a video on that. Just look for it and you would see. Okay, so we're taking that worded equation and we're going to convert it now into the equation using symbols. So for magnesium, we have Mg, and it's a ribbon. So a ribbon here means that it's solid. Okay? Ribbon, powder, lumps, clumps, you know, all of those things could convey something that is solid. Okay? The hydrochloric acid is a solution. So we have HCl aqueous. Okay, that means it was dissolved in water. You're paying attention. Good. Then we have the magnesium chloride, MgCl2. If you're still wondering how that 2 got there, you need to go back and watch my previous video. All right? And it's aqueous. So what does that mean again? Dissolved in water. And hydrogen gas, H2G. Nice. So we have our equation all written out in terms of the chemical formula and state symbols. What do we do next? Step 3. Balance your equation. Now, an equation is not an equation unless it is balanced. So if you have gotten through step 1 and step 2 really well, then you've only gotten a fraction of the marks that could be credited. But if your equation is not balanced, then, well, you've missed a big chunk of something important. So what do we mean by balance? It simply means that there must be the same number of atoms or ions of each element on both sides of the equation. So if there's 1 magnesium on the reactant side, there should be 1 magnesium on the product side. Keep it balanced. If you find that your balance is going this way, that is not balanced. We need to do something about it to keep the numbers at the same. So what is it that we can do? Now, there's only one thing you can do. And if you find that you're doing something else to get your thing to balance, something is wrong with that equation. So what is that one thing you can do? You must place a whole number in front of the chemical formula. You hear me say? I said in front. I didn't say behind. I didn't say between. I didn't say on top or underneath. The only place you can place a number is in front of the chemical formula. So let's look at our balanced chemical equation there. Let's take a look at it. So zone in, we have the magnesium. We have 1 magnesium there. There's no number, so 1 magnesium. And on the other side, the product side, we also have 1 magnesium. Very good. That 2 does not belong to the magnesium, people. No. Leave the 2. That's the chlorines 2. Okay. Now the hydrogen. Take a look there. We have placed a 2 in front of the hydrogen. Okay? So the 2 is actually in front of the hydrochloric acid, is in front of the whole thing. All right? So that means we have 2 hydrogens and 2 chlorines. Okay? So by placing a number, a whole number, in front of the formula, that means that we have changed the number of each atom associated with that chemical. Are we together? I hope so. Good. And when you place a number in front, it means multiply. So when you're looking for the number of hydrogens, it's 2 times 1, not 2 plus 1 because that's another number. Okay? So 2 times 1, and for the number of chlorines, 2 times 1. Okay? Good. So that is our balanced chemical equation. There are 2 hydrogens on the reactant side, and there are 2 hydrogens on the product side. See them there? H2. Good. And there are 2 chlorines on the reactant side and 2 chlorines on the product side. Nice. That was an easy equation to balance. Let's try something else now. So here's what we're going to look at: a chemical reaction. Now this reaction is between the iron, some iron filings, and sulfur powder. Good. Now if I just took iron and mixed it with sulfur, not a thing would happen. It would just be a mixture of iron and sulfur, just a mixture. But when I apply heat, look at what happens. A new compound is formed. It's called iron 2 sulfide. Okay? So that's a reaction taking place. So just by applying the heat, we get a new reaction taking place. Now take a look at the equations expressed in words and then expressed in symbols. Oh, which one would you rather write? Would you rather write 1 mole of iron solid filings reacts with 1 mole of sulfur solid powder in the presence of heat to form 1 mole of iron 2 sulfide? Or wouldn't you just love to write that little equation there, nice and short and simple, Fe, solid plus S solid, arrow, heat, and FeS solid. Which one is easier to write? I hope you would say the shorter one. Now take this into consideration. The iron and the sulfur are reacting together, look at the equation, to give you iron 2 sulfide. Let's see if this equation is balanced. How many irons are on the reactant side? There's no number. Hint, hint. Good. That means there's only 1 iron. How many irons are on the product side? No number again. So 1. So the irons are balanced. Let's look at the sulfur now. On the reactant side, how many sulfurs? Just 1, no number. On the reactant side, on the product side, sorry, just 1. So this equation is like the easiest of them all. It's just naturally balanced. Good job. So now let's look at some common laboratory reactions, and we are going to write the balanced chemical equation of each.
They'll just pop, and that's not very exciting. So again, bubbles filled with 2 parts hydrogen, 1 part oxygen. What I would need you to do is scoop up as many bubbles as you can, but leave the water behind.
Okay.
All right? So get as many bubbles as you can. Okay, then open your hands up flat for me. And we're gonna scoop those down a little bit. All right, we're gonna see what happens when we add a little bit of energy to that.
Everyone has their ears covered, Carl.
We're gonna have a little bit of energy to combine those 2 atoms together. Here we go. 3, 2, 1.
Oh my God!
Isn't that amazing?
I'm gonna have a heart attack.
No, show them your hands.
Isn't chemistry awesome? Look at that. The bubbles contain hydrogen gas. And when hydrogen gas is burnt or reacted with oxygen, it produces a very loud explosion. And it also forms water. Let's write the chemical equation for this reaction. So, what did we have? We had hydrogen gas reacting with, that's my plus, reacting with oxygen gas. Are you seeing this? What should come next? Those are my 2 reactants. What should follow? The arrow. Good. And what is the product? Water. We got water. Great. So we have our worded equation. Let's now convert this into our chemical equation. The formula of hydrogen gas is H2. All right? And it's a gas. So what symbol should I put here? G. Very good. It's reacting with oxygen gas, O2, and it's a gas, so G. Wonderful. Arrow, the product. Do you know the formula of water? H2O. We're going to keep it as a liquid. Great. So we have our unbalanced chemical equation. Let's see if we could balance it now. We're just going to look at it. I want you to look at this equation and tell me what's not balanced. Let's go one by one. Hydrogen. We have how many hydrogens here? Very good. We have 2 hydrogens. How many hydrogens do we have over here? 2. Very good. So are the hydrogens balanced? Balanced. Okay, great. The oxygens. How many oxygens here? 2. Wonderful. How many oxygens here? Did somebody say 2? Leave the hydrogens 2 alone. No number means 1. Good. So are the oxygens balanced? No, it looks like this side is a little heavier. All right. So we have 2 oxygens here, but we only have 1. I want to balance it. So what do I do? Yeah. So I should put a 2 here, shouldn't I? Yeah. Because you've been paying attention. I should put a 2 here. No, don't do that. Don't put any number in the formula. The only place you can place a number is in front. So if I want to get 2 oxygens, I have to place my 2 here. 2 times 1 is 2. So now I've got 2 oxygens. But look here. When I place that 2 here, I change the number of hydrogens. Is that 2 plus 2? No, it's 2 times 2. Same number it will give you, but still. Right? So now we have 4 hydrogens. But how many hydrogens do we have here? Only 2. So I need 4. What number can I place here to give me 4? What number times 2 is 4? Very good. If you said 2. So let's look at our equation. Always double check. So we have 2 times 2, 4 hydrogens. We have 1, no number here. So that means we have 2 oxygens. Over here we have 4 hydrogens and 2 oxygens. That equation is balanced. Give yourself a clap if you got that right. Nice. Now, here's a tip. When you are writing your equations, when you're writing them, leave spaces in front. Leave spaces in front of formulae so that you could, fit the number in. If a number is needed, you need to leave the space. Okay, let's look at another video of a chemical reaction in the lab, and then let's balance it.
A small piece of sodium metal is placed in a flask containing yellow chlorine gas. The flask also contains sand to prevent the heat which will be generated by the reaction from cracking the glass. Initially, no reaction is observed between the sodium and the chlorine. The reaction will be initiated by adding a drop of water to the sodium.
I told you chemistry is awesome. Look at that. When you place sodium metal with chlorine gas, you get another explosion. This is an explosive morning, all right? And it produces sodium chloride, as in salt, as in table salt. Would you eat that? Did you see that sodium? It just took 1 drop of water for that whole thing to go up. Boom. But you know what? When you react, substances, they change their properties. So sodium is no longer that highly reactive metal when it becomes bonded with chlorine. Let's go. So this now is our worded equation for that reaction. Let's convert that into a balanced chemical equation. What's the formula of sodium? Na. Somebody said S. That's sulfur. Okay, it's a metal. And you saw the guy, he placed like a piece of it. So what state should I put? Good job if you said solid. Good. So we have solid sodium reacting with chlorine gas. So Cl2 gas. All right. to give you sodium chloride. Everybody knows the formula for sodium chloride? NaCl. And it came off as a powder. Okay, so powder, solid. Take a look at the equation. Is it balanced? Yes or no? If you said no, you're correct. We have 1 sodium on this side and 1 sodium on this side. So the sodiums are balanced. But look at the chlorines. We have 2 chlorines on the reactant side, but there's only 1 on the product side. I need to get 2 chlorines over here. What do I do? Yeah, stick a 2 right here. You got to pay attention. You got to pay attention. We can only place the number 2 in front. So when I place the number 2 in front of the sodium chloride formula, I now have 2 chlorines. So the chlorines are balanced, but I changed the number of sodiums. So now I have 2 sodiums. I need to fix this. Over here, I only had 1. So what do I do? Very good. Place a 2 here. And this is the balanced equation for that reaction. Isn't chemistry awesome? Nice. Let's take in another reaction.
And then we'll drop it, we'll add it into the chlorine gas. Now instantly we're seeing aluminium trichloride coming out of the top and reacting with moisture in the air. So now you can see the reaction is getting very intense and we're seeing a flame in the bottom. So the aluminium is being consumed as it's reacting, oxidizing in that chlorine-rich environment.
Right. So just adding sodium to chlorine gas makes sodium chloride. And just adding aluminum metal to chlorine gas gives aluminum chloride. But guess what? We needed to apply some heat. Oh yeah, because nothing would have happened. With the sodium, all you needed was a little drop of water to spark it off. But with the aluminum, we need some heat. Okay? So aluminum reacts with chlorine gas. It's just like you're taking the 2 atoms and you're just smashing them together, 2 elements, and just smashing them together. We have a name for that. You call it direct combination. Direct combination. All right, so let's write the chemical equation. So we have aluminum metal. Was it liquid metal? No, it was solid. It was a piece of foil. We had chlorine gas, so remember that, Cl2. In the presence of heat, we got aluminum chloride, AlCl3, and solid. Okay? If you're wondering where that 3 came from, you need to learn how to write your formulae. Okay, so let's go. Let's balance it. 1 aluminum here. 1 aluminum here. Aluminums are happy. 2 chlorines here. But hello, 3 chlorines there. Can I make this 2 into a 3? Remember, we're multiplying. Is there a number I can place here to make this 2 become a 3? Absolutely not. We got to try something else. And you know what? When you're balancing equations, sometimes you just have to start with pencil, rub out, and try again. Okay? So let's try, if we try a 2, if I put a 2 here, let's just say we put in a 2. How many chlorines would I have now? 4. Can I make this 3 into a 4 by multiplying it by a number here? So you know what? Get your eraser and rub that out. Not working at all. So try again. So we tried a 2. Let's try a 3. All right. So 3 times 2 is 6. Can I make this 3 become a 6 by multiplying it by a number? Oh, yes. Because 2 times 3 is 6. So I can place a 2 here. So now I have 6 chlorines and 6 chlorines. But I changed the number of aluminums. How many aluminums do I have now? 2. So I have 2 aluminums here. So what would I need to do? Put a 2 here to balance everybody. And that is your balanced chemical equations. So you just have to try sometimes. Erase and try again. All right. So why are we in the lab? We got to do some, don't you think so? We got to get our hands dirty. And I just love to get my hands dirty in the lab. So for our next reaction, I'm going to do it. You're going to observe, and then we're going to write the balanced chemical equation. Let's go. So the reaction I'm going to do is between sodium carbonate and we're going to use some hydrochloric acid. So if you want to see what sodium carbonate looks like, it's just a nice, can you see this? Just a nice white powder. Okay? Good. So we're going to add a carbonate and the acid together. So I have already placed some in my test tube. And let's now add some acid to it. Okay? So here we go. Can you get in there? All right. Chemistry. Are you seeing that? Okay. So the sodium carbonate is definitely reacting with the hydrochloric acid. We have a reaction going. There it goes. Yeah, it looks like it needs some more. Oh, yeah, now we're talking. Yeah, now we're doing some chemistry. Oh, it's making spills and thrills. All right, good. So what is happening in here? The sodium carbonate is reacting with the hydrochloric acid to form sodium chloride, water, and carbon dioxide gas. Let's write our worded equation and then our balanced chemical equation. Let's go. So we got sodium carbonate was definitely a powder reacting with hydrochloric acid, and that is a solution to give you sodium chloride. Well, we're using all this board today. And that was solution, water, and carbon dioxide gas. Yeah, we're using all the board. Take that in. Good. So let's go quickly. So sodium carbonate is Na2CO3, and it's a solid. The hydrochloric acid is HCl. It's solution, so we write aqueous. We put our arrow. We get sodium chloride solution, water is liquid, and carbon dioxide, and that's a gas. All right? So all of that was happening when we did this reaction. Okay? We still have some sodium carbonate at the bottom that is unreacted. So that means we probably need to add some more acid. But what is being left behind after all that effervescence is sodium chloride and water, the gas left when it effervesced. Okay? So we got some salt water in here. Definitely. All right? So take a look at the equation and let's see, is it balanced? So let's get the full equation and let's appreciate it. Is it a balanced equation? What's not balanced? So we know it's not balanced. What is not balanced about this equation? Good, the sodium. The sodium is not balanced. We have 2 sodiums here, but we only have 1 sodium here. Okay? What about the carbon? Is the carbon balanced? We have 1 carbon here, 1 carbon, and over here we have 1 carbon. So the carbon is balanced. Is there anything else that's not balanced? What about the oxygens? We have 3 oxygens here, 3. Over here, we have 1 oxygen plus 2 oxygens gives you 3. 1, I'll do that again. 1 plus 2 is 3. So the oxygens are balanced. The hydrogens, we have 1 hydrogen here, but we have 2 here. Hydrogens are not balanced. And the chlorine, we have 1 chlorine here, and we have 1 chlorine here. So right now, our sodium is not balanced, and our hydrogens are not balanced. So what are we going to do? Balance them. So we're going to place, let's start with the sodium. That's the easiest one. So we have 2 sodiums here. How can I get 2 sodiums over here? Place a 2 in front of the sodium chloride. Now when I did that, always look at what you've done. When I did that, I changed the number of chlorines as well. So now I have 2 chlorines, so I have to go back and balance the chlorines. So how many chlorines here? 1, I need 2, so I have to place a 2 here. When I did that, I affected the number of hydrogens. So now I have 2 hydrogens here, and I have 2 hydrogens here. Always double check, is everything balanced? Take a good look. Is it balanced now? I always double check. Even with many years of doing chemistry, I still double check. Always have to double check. Are we happy? Is this a balanced equation? Yes, it is. All right? Good. Let's do another reaction. One more. Now this reaction we're going to do is the thermal decomposition of copper 2 nitrate. Copper 2 nitrate. Copper 2 nitrate. And we actually have the crystals. So let me get fancy and write crystals. You know, I could write solid, but I just want to be fancy. Okay, so it's the thermal decomposition. So that means we're going to be applying some heat. Okay, so we just start with that one substance, and we're going to decompose it. We're going to heat it until it breaks down into other substances. So what are those other substances going to be? We're going to get copper 2 oxide, and that's going to be a solid, so look for it. We're going to get nitrogen dioxide gas, so look for that. And we're going to get oxygen gas. Well, oxygen gas, well, you could look for it, but you might not see it. Okay, so this is the worded equation for the reaction that we're going to do. So let's do it. All right, so let me see if I could take out some, just so that you could appreciate that it's crystal. Can you get that? Can you? Oh, you don't know how this color gives me life. Look at that. All right, so these are copper 2 nitrate crystals, and we're going to decompose them thermally. So that means we're going to heat it. Good. So as we're heating, let me teach you a little bit about heating. When you're heating a dry solid, there are a couple things you want to take note of. Don't grip your test tube, or in this case, this is a boiling tube. Don't grip it too low because conduction, you will get burnt. Okay? Don't grip it too high because that's just careless. That's just being careless. You might slip out and break. So you want to grip it just right. Just right, okay? The next thing, you want to make sure it doesn't have any cracks because, well, yeah, it will break. Okay, and when you're heating, you want to heat strongly, but you still want to pass the tube through the flame. So you're going to aim for the blue part of the flame, and you're going to heat it strongly and still moving it, okay? Now, I haven't started heating yet. We have to get these things right, because if you go in the lab and you don't get it right, you're going to have problems. The next thing, the mouth of the tube should be pointing away from you and others. If you are heating it and you are pointing it at your neighbor, then you don't like your neighbor very much. Yes, I said that. And if you are heating it and you are pointing it at yourself, what I mean, you like yourself very much. Okay, so point it away from yourself and from others, and you're going to heat it strongly. Okay, so let's go. Keep your eyes out. We're looking for copper 2 oxide, nitrogen dioxide gas, and, well, there will be some oxygen gas. But you won't see that. Maybe we could test for it. Okay, so immediately we are getting something is happening there. Oh, yeah. Okay, so we definitely have a gas coming off there. Okay, are you seeing this? I can tell you, I'm smelling it. Okay, so something green is happening there, but that's not what I want. I want copper 2 oxide, and copper 2 oxide is not green. No, look at that. Do you see that? There's a brown gas coming off there, and if I was to test it, I would get, whoo, that's strong. I would get a positive test for an acidic gas. So there you have it. And look in the tube. Can you see that? Can you zoom in on that? In the tube, there's this black solid that remains. That black solid is our copper 2 oxide. Okay? And that brown gas with an irritating smell, irritating smell, is nitrogen dioxide gas. Let me get rid of that bad boy. Take one last look. One last look. Good. There would have been some oxygen coming off as well. I don't know if we could. How do you test for oxygen? I'm not guaranteeing you anything here because we did heat it earlier. With testing for oxygen, you want light this splint, out this splint. Should be glowing. This one is not glowing. We're looking for this splint to relight. Oh, did you see that? Chemistry in action, I tell you. Do it again for me now. I just feel alive when I'm in the lab. You're not going to do it twice? Okay, maybe I was being... But you can see definitely it's glowing more when I put it in. So it wants to. All right, good. So when we have strong gases like these, we put them in the fume cupboard. So I'm going to put this in the fume cupboard and let that do its thing over there. Right. So let us balance our final equation. Write it and balance it. Let's go. Copper 2 nitrate. Cu, copper 2, NO3, 2. That's copper 2 nitrate's formula. Crystals, not a fancy word for solid. We heated it, and we got copper 2 oxide, CuO, and that was solid. That was the black solid. So we started out with blue crystals, and we got a black powder. We got nitrogen dioxide gas, that's NO2, gas, and oxygen gas, O2 gas. Yeah, we definitely saw that. Did we see that? Did you see that? It relighted a glowing splink. That's oxygen gas. So let's balance this one. Let's go. How many coppers here? 1. How many coppers here? 1. Balance. These brackets, what do they mean? Same thing in math. Anything inside the brackets gets multiplied by whatever is outside. So how many nitrogens here? 2. Good. How many over here? 1. Not balanced. How many oxygens? 3 times 2 is 6. How many oxygens over here? Oh, they're all over the place. 1 plus 2 is 3, plus 2 is 5. Huh, what a conundrum. What are we going to do? What are we going to do? What are we going to do? We just got to try and get your eraser and try again. All right, so let's go. The first thing I think we could try is, let's try to balance the nitrogen. So if we try to balance the nitrogen, we have 2 here. We could try to make a 2 here, but does that fix anything? No, we still have the oxygens to bother about. So we have 1 plus 4 is 5, plus 2 is 7. Then we can't turn a 7 into a 6 or a 6 into a 7. You know what? Maybe we should just go up. So erase that and try another number. Let's try a 2 in front of the copper 2 nitrate. So now we have 2 coppers. So we need 2 coppers here. We have, good. We have how many nitrogens now? 2 times 2 is 4. 4 nitrogens. Here we only have 1. So what number are we going to put here? 4. Good. So 4 times 1 is 4. Nice. How many oxygens do we have in total on this side? We had 6 here. 2 times 3 times 2 is 12. So we need 12 oxygens to be on this side. So let's check. 2 oxygens here, so that's 2, plus 2 times 4 is what? 8. So 2 plus 8 is 10, plus 2 is 12. Yay! So we've balanced this equation. Okay? So that is a balanced chemical equation. All right? So what did we learn today? We learned that it is important to write balanced chemical equations because writing balanced chemical equations help to simplify things for us when we are doing our chemistry. We don't want to have to keep writing out these long sentences all the time. So a shorthand way of writing an equation is the best way to go. If you're going to balance a chemical equation, you need to follow the steps. Remember, write the equation in words. Write the equation in words. Then you're going to convert those words into chemical formulae and state symbols. And finally, you are then going to balance the equation. If you're balancing an equation, remember, you can only place a whole number in front of the chemical formulae. Okay? That's the only place you can place the whole number. Can we take a pause? now that you understand how to write balanced chemical equations, please take in the next slide, which is a practice of writing some balanced chemical equations, and you can pause it there and write your own chemical equations. Following that, there are the answers on the next slide. Right, so that's your practice time. Thank you for joining me in my chemistry lab today, and do have a great day. Bye.